The Government Committee of the French Quarter Management District. Today we have a guest speaker, Dave Woolworth, and he'll be making a presentation to us on the science of sound and addressing some of the individual issues. What I'd like everybody to do is on each of your tables, you've got a sign-in sheet. Please sign in, and you know, your affiliation or your interest, whatever it is, mark that down. And then also, I would like everybody to go around and just indicate their name and who they represent, or you know, just briefly, like I'm a resident, I'm a business owner in the quarter, I'm a musician, whatever, like that. Or if you're a city council representative, staff, then and that too. Anyway, I'll start. I'm Kim Rosenberg. I am the Vice Chair of the French Quarter Management District and the Vice Chair of this committee.
Robert Waters. I'm the Chair of the French Quarter Management District and a member of the committee.
Anna.
Hi, Hannah Krieger-Benson. I'm a member of the Government Committee. I'm a resident of Mid-City. I make my living as a musician, and I'm also the spokesperson for the Music and Culture Coalition of New Orleans, known as MACNO.
I'm Willie Davis, a piano player, resident off and on since '77, and a big believer in being a good neighbor. Love New Orleans.
And we thank him for filming the whole presentation, and it'll be uploaded onto YouTube.
I'm Bob Sims. I'm a resident of the French Quarter, also a member of the French Quarter Management District Government Committee.
I'm Gail Cavett, and I chair the Infrastructure Committee for French Quarter Management District, and I'm also a member of the board for French Quarter Citizens.
I'm Alex Chasik with Councilmember Palmer's office.
Sir?
Rich Webster with the Times-Picayune.
And Andrew Vandercourt, the one on that.
I'm Ruth Jalea, resident in the French Quarter.
Sandra Stokes with the Louisiana Landmark Society.
Okay.
I'm Lori Hutton, a retired engineer. My husband and I come down here for 3 months out of the year, so we're spending our winters in New Orleans with you guys for the next, as long as we can.
Okay.
Asante Salam from the Mayor's Office of Culture Economy.
Travis Palmer with Razoo Business on Bourbon Street.
Peter Caligari, also with Razoo. Alex Fine with Corti Sisters.
Jude?
Jude Marullo, member of the FPMD Government Committee, and also live venue operator. Live music.
Larry, why don't you?
Larry Haskell for the Record Review. Craig.
Mark?
Mark Wilson, General Manager of the Bourbon Orleans Hotel and Chair or Co-Chair of this committee, Government Committee.
And we thank him very much for being our host. Sir?
Rich, proper doing.
Okay.
Orleans Shealy, part-time resident and business owner of the quarter.
Jerry Spear. I'm not in the quarter. I live uptown in the Carrollton Riverbend area. I'm interested in the sound issue. I'm an appreciator of the culture, but I'm also a member of my neighborhood association board and dealt with good neighbor agreements with bars in that area. And I don't represent them or the Alcoholic Beverage Control Board, but I also serve on the board, and we often hear complaints of noise complaints.
Welcome. Sir?
Rich Campanella, just interested in the issue.
Okay. Sir?
And Jonathan Harris from Stacy Head's office.
James Kahn, resident.
I'm Brenda Martin. I'm an artist on Jackson Square.
Harry Shearer, I'm a resident of French Quarter, an alleged musician, and also a plaintiff in a noise lawsuit.
Okay.
Michael Mangold, I'm just a journalist.
Carolyn Goodwin, French Quarter resident. Beth Levitt, resident. Leslie Stokes, resident.
Brian Drew, resident. Bill Moore, resident.
Benjamin Malin, resident. I'm also the chair of French Quarter Management Enforcement Committee.
Heidi Dibblin, resident and business owner.
Ryan Williams, I'm a musician, American homeowner, and member of MACNO.
Okay. And I think, sir, you came in late?
Yeah, Bob Fryvick. I'm not a resident of French Quarter. I just write some stuff about this.
By water bottle.
Well, I would.
Okay. And Gail, did you go around already? Oh, we did. Okay. And did anybody else come in late and hasn't?
John McCusker, New Orleans Ave.
Thank you.
And I'm Prescott Stokes III, Times Picayune.
Times Picayune, okay. And sir, are you in the striped shirt in the back? Your name and...
I'm Brian with Channel 6.
Okay, thank you. All right. Now, everybody don't forget to sign in on the sign-in sheets, and you'll also find some papers that our guest speaker will tell you about in a moment. Our guest speaker is Dave Woolworth. He is an acoustic engineer, and he has been retained by the City Council for his expertise in the science of sound, and he will be working on the sound ordinance and on the city's soundscape. And without further ado.
Thank you, Kim. I'd like to thank everyone for having me here today, or for everyone for coming, and FQMD for government for having me. I'm working with the City Council at this point, and we're trying to investigate the Ukraine Entertainment District and create recommendations for regulations. Let me start out here with, let me find it first. There it is. Okay. I don't need that. All right. We're really here for educational purposes, to understand where we're going, so that you get ideas on, understand what the general idea is we're heading into with the Ukraine Entertainment District, and also learn a little bit about measuring sound, because it's where a lot of confusion exists when we get to dealing with metrics and sound levels, okay? Today we're going to start here. Can you see okay for the light? Is the lighting all right for you? All right. Okay. We'll do an overview of what we're getting into right now, and then we're going to talk, the lion's share of it will be talking about sound measurement. We'll be doing some examples, and then we'll get into talk about enforcement a little bit here, and then at the end, these forms, and you can feel free to fill them in during this if you feel like it. But I'm interested in getting people who want to give feedback, get involved. I want to understand if anybody has any ideas, and if people want to volunteer in terms of understanding the nature of complaints. It could be bars complaining, it could be residents complaining, anything. But understanding the nature of those complaints and how we have to identify the problems. We've already done this on the first stage of the soundscape study, but I think here we have a chance to re-examine it. And that's very important. The more we examine it, the more things fall out the same way, the more we can identify these problems, and hopefully start targeting these solutions. So what's going on? Who's involved? Well, the City Council is engaged, yours truly, and we're involving the stakeholders, which are all the people who are here, and I believe some of you are all representatives, and also at the end we have the health department, who is ultimately going to shoulder the burden of dealing with the enforcement. So they have to be, they're not here today, but they will be, I'll make sure of it. So what are we going to take care of on this particular phase? The focus, and look at this, this contrast is terrible here. The focus here is recommendations for the VCE sound ordinance, including metrics, limits, and methods. So we have to understand it's not just a sound level, but it's how it's measured. Okay, and we're going to get into that today here. We're going to look at, in this, the original report dealt with VCE facades, the facades of buildings all up and down Bourbon Street. Now that was a very important first step. Courtyards are a little more complicated, but what we've chosen to do is in this phase, enter that into the equation and see if we can't solve that problem, or at least present a solution or a partial solution to that problem. Because we have courtyards that border right up to residences. And the courtyards are where there's a lot of activity. So we're starting in on that. And again, anyone who, when we talk about feedback, if people have resources for this or want to get involved in that, there's a lot that we can, I could use your help. Now, why is this happening? Well, over time, things have gotten too loud. That's what it's come down to. There may be people who disagree with that, but I think the majority believe that it's too loud. It's not too loud all the time, but it's too loud often enough that creates a problem for residents and and for other people, okay? And we have at the bottom, sorry again about the contrast here, health and safety issues that are related to that. You have the health of your community, you have the health of your workers, and you have safety issues regarding police communication. So those things are going to be things that they must be addressed at this point. When is this going on? I'm going down the who, what, why, when, where, and how, right? Today, you're here. On the 24th, we're going to have another meeting, and we're going to discuss, we're going to focus more on owners, operators, musicians, DJs, and the public, of course, is invited here. But we want to get more coordination. We want to see if we can get more people involved in this. And we're going to talk about, I think a lot of it will cover sound control. All these different methods that we can use for sound control and ways we can help reduce sonic footprints. And I think that's going to be valuable information for these folks and the public, but or general public. But I think these folks will benefit from it, and we can further discuss some of the items that we're getting into and how we might go about creating these solutions. Finally, March. After that, we're going to go out for a few measurements on the street with anybody who's cooperating. We maybe get some folks to cooperate, some bars to run some tests, and we'll run some tests ahead of time to show the effects of different things, how we might be able to do things. So we get an idea, because we really need to put numbers and metrics onto these things that we're doing, because there's a disconnect sometimes. And so we need to connect these things. So then on March 6th, we're talking about hopefully a larger scale test that actually compares some of the current levels to the levels that we're projecting. Doesn't mean we're going to actually be soundproofing the places. We're going to just use the sound levels themselves. So residents can understand the impact of what we're discussing, what we're trying to accomplish. Owners and club owners can understand the impact of what we're doing, what it's going to sound like. The police can understand it, that kind of thing. Right? We may require additional meetings and testing. I don't know, but we're going through a process. And then finally, at the end of March, we're going to have recommendations to the city. So there's going to be an opportunity in there to discuss more things, analyze information that we have, and get more feedback. And the idea, again, is transparency is critical, and that we get involved, the public involved. That is all our stakeholders. Okay, well, we know where it is. We have the VCE marked clearly on Bourbon Street, and there's also a VCE section here on Decatur. Now, I don't know that we're going to be, we have to dig deeper in there. I've not heard very many complaints down in that area yet, but hopefully we maybe dig out some things if there are issues there. But for right now, we have a very complex situation on Bourbon Street that is a mixed-use environment. Okay? How are we going to do this? Well, we're going to make some field measurements, as we discussed. We're going to collect more information to refine the initial recommendations, which are in the soundscape report. Okay, there was a set of recommendations for Bourbon Street, and VCE, I should say, and then we relate these to acceptable material levels of feedback from the stakeholders. So we need to understand what everybody thinks of it, and how they want to understand how we're going to get there, but also making sure that the people who are on the receiving end, who maybe don't necessarily want the sound in their dealing with unwanted sound, have acceptable interior levels in their residences. That's our target. Okay. What are we measuring? Well, we can measure things. We're going to get into sound metrics and measurements now. What can we measure? We can measure industrial sounds, and there's methods for that. We measure sound at concerts. We also measure environmental sounds. We also and that includes community. So we have community impact studies. This is not your typical consulting job, I can tell you that. Okay, but we need to know that there's all these different ways to do things, and there are metrics associated with it. Okay, let's talk about formation of a decibel level. We're going to get into more interactive and I don't know if the correct pronunciation is demonstrative, but I want to demonstrate what I have here. We're going to let's get off the PowerPoint for a second. Thank goodness. Let's get into some measurements. Let's see what we have here. This is a sound. This is some readings from a sound millimeter that's operating right now. Okay, as I speak. So you're getting my speech pattern. You have LA equivalent up there. We're going to talk about these metrics in shortly, okay? Let's take a look. Let's go backwards here for a second. I'm going to take you over to here. Oh, I'm sorry. We'll get out of that. Stop that. Okay. Here we are. This is the frequency spectrum from low to high, okay? And it's broken down into more of what the signal actually looks like, okay? This all becomes a number. All this turns into a number. When I speak, you can see here in the middle, the mid-range is where a lot of the speech is. So my voice covers that range. If I stop speaking, you see all this noise down here? That's all the ventilation system making noise, okay? So you get an idea what's going on. Is the ventilation system loud? You can hear it, but it doesn't seem terribly loud, but it's a little bit loud because I can hear it, right? But compared to my voice, it looks like it's almost as loud, but you clearly hear my voice a lot louder. We're less sensitive to low frequencies. There's low frequencies all the time. But we also, once we start hearing them, small increases influence, we hear them, the increase is noted a lot more, okay? So we're taking a look at this. The next thing that happens with something like this is it's broken down a little further. Let's get over here. Let me get this guy to go. Then we can break it down. We add those little bands together, and now we have bigger bands, okay? Here's my voice again, right here in the middle. There it is. So that's now this all turns into what? It turns into a number. So we can't really backtrack so much and understand what it is. Where did that number come from? You can't extract all that information back out. But you can. But that's how decibels are formed. They take all the information, you compile it finally into what they call third octave bands, the smaller ones, octave bands, and they all add them together, and that's logarithmically. It's a little different. If you add two numbers of the same, it's 3 up. There's a set of there's a mathematical formula, and then there's a simple way of doing it as well. It's a rough method. So that's what you end up with. If I start it again, let's start again and listen, and then I'll start talking. You can see the difference in the levels. So you see right here now, we just had these levels down at 45 decibels, okay? And I start speaking and now I'm up at 60, okay? That's important to notice. Now, what has happened down here with this, we'll get that in a minute, but it's LC, which takes in low frequencies. You see that, let's move on from here. I just want to show you how decibels are formed, and let's go ahead and try this again. Measurement weighting, let's see. Formation decibel level. Now let's take a look here. We have these two things. One thing is called A weighting, which you'll hear about all the time, and that's what's in the ordinance right now. And then C weighting is what we're going to get into and discuss why it might be needed, which is what I'm going to say right now. C weighting is used, and you can't read this so well from where you are. C weighting is used to simulate human hearing at higher sound levels, and it includes low frequencies. Okay? A weighting is used to simulate human hearing at lower sound levels. So at normal conversation levels, A weighting is useful in normal sounds that we hear, and that's what we use to determine annoyance. And it's a sort of a standard. But we now have other things. These days we have new situations that have arisen because we have more efficient loudspeakers. Music is different. And we have a lot more low frequency content, a lot more low frequency noise, and so we have to consider them. Okay? Why is it important to us? Because it's prevalent all through the VCE that we have a lot of low frequency pulsing noise. We have to find a way to measure it and understand it and say, okay, this is the limit to what we have. We can't go over this limit, because these people are affected by it. So when you say weighting, what does that mean? We saw those fingers jumping up and down, right? All the frequencies. Well, this is what it does to it. The A weighting cuts out the low frequencies. So that's why you've heard of examples probably in our community where somebody says this low frequency pulsing is driving me crazy. They come out with a sound level meter and the A weighting cuts out the low frequency, so there's no violation. So what do? Well, they're within the law. Well, it turns out that the law doesn't cover that. So that's why we're talking about redeveloping it so that it does cover it. Okay? And here, C weighting cuts off things below, let's see, this is 20, 30. At about 30 or 40 hertz, it starts to roll off. So back here in 60 hertz where the bass drum lives, it's in part of the measurement. Okay? Now, that doesn't mean that the levels, you're not holding something the same standard for A and C weighting. They have to be different numbers because they have to reflect what the actual acceptable sounds are. But now you know that. Let's take a look at what happens to sounds when we actually weight them. Okay, I'm going to show you an example so that way we get a better idea on the hands-on. Let's take a look. Now here's the room. Okay, you'll have to ignore these numbers over here because we're not dealing with a calibrated microphone. We can look at the shape of the signal. That's my voice. And that's the room right there. Okay? Let me put on an A filter for it. You'll see all the low frequencies disappear. Okay? So now it's all gone. I'm going to put it back. And let's look at C weighting. Cut off that little part at the end. Let's go back to our 1/3 octaves. This is what you were seeing before. You can see my voice in the middle. And I take the A weighting. So the room noise is right here. Okay? Take my A weighting. It's all gone. I take my C weighting, I bring some of it back so I can measure it. Now, this is it. Let me reset this. Reset. And what I'm going to do now is I'm going to ask you, I don't know if we're going to get it, how accurate it's going to be, but we're going to, well, we'll do it with the sound level meter because I think it would be better. What we're going to see is that my voice doesn't have a lot of C weighted information in it. And that's something that we have to take into consideration. People don't necessarily create C. It's probably from machinery and from music. I say low-end music, okay? So those are the two sources we have to contend with, and that's, when we do with machinery, it's very important as well. Nobody wants to sit next to an air conditioner all night, right? So, just wanted to show you how that works. Let's go ahead and move on. Okay. We have a time weighting. And you'll see in our time weighting, there's what they call fast and slow, and what they call equivalent, all right? And the fast and slow were some of the original metrics, and they were done when we used analog meters. We had capacitors and resistors and a network, and everybody had to eyeball and watch it just flick through numbers. And you'd say, oh, I just saw it. And there was no way to log it, okay? It was all analog. Right? Then we reach the digital age, and now we can measure these things again, but we have what they call equivalent, which measures every 1.3 milliseconds. So it's hearing continuously, and it's what they call equivalent continuous sound. So you get an idea. So here's what's going on. This blue line is A weighted, slow reading over a long period of time, and this LEQ is here. It represents sort of how we perceive it. So that's what we're doing now is we're saying, okay, well, and there's another reason why we're looking into LEQ. That number one, or several reasons. One is the World Health Organization uses LEQ. Okay, ever since the advent of it, that's what they use. The federal government uses it. The EPA uses it. All the large organizations use equivalent levels because it's useful. Housing and urban development. Okay, transportation, Federal Transportation Administration. So they're all using LEQ, and for reasons because it helps them. It's a modern metric, and it measures continuously, and it allows us to understand a lot better what we're perceiving. Now, some of these large things are out of the way, but these are momentary. And then we have a set of events that are allowed. It says, hey, that sounded loud. And actually, it matches a lot more of what our perception is of what's going on. Okay? It doesn't mean that fast and slow don't have their place, but there's another reason. There is a metric that they use to understand the impact of low frequencies and it's successfully used in Europe and other places, is that they have LC EQ minus LAEQ, and if the difference is so much, then you know that it's going to be very noticeable. And they use it successfully to control sound when you have these old cities like you have right here. And so without having to invent a new metric, something exists that actually shows that a problem may or may not exist. Okay? And so that's another reason why we would consider this metric, using equivalent. Because there's no comparison for fast and slow, and then evaluating it against low frequencies. There's no standard. Okay, and I don't think that New Orleans is ready to develop their own standard in that way. I think they're ready to get on with some things. So the time of measurement. How long should we measure? We have to capture the relevant information. And it turns out that with low frequencies, we have to deal with 15 to 20 seconds to capture a decent amount of information, understand how much low is going on. Okay? You can do shorter with higher frequencies. But if we're trying to capture low frequencies, we need 15 to 20 seconds. If we keep it down there, then we have it at where we can make multiple measurements in a short period of time. Say, well, I measured 3 times and it's all over, or maybe we had one time where it was over and the rest of it was fine, that kind of thing. But if we need to make multiple measurements, if we need them from different places, it's not going to take all day. So that's another reason why we may go shorter. Miami, I believe, I'm thinking it's Miami, their entertainment district uses a 20-second measurement. Okay, so it's not unknown, but currently we use a very long and arduous process in the VCE. And it actually becomes, it's burdensome. The police have decided, and we'll get into enforcement, but the police and the trainers have basically said that it's near impossible to work with. So it's a good reason to move away from it. You have, and well, that's what it's right here. Keep it simple for enforcement. If we have a shorter amount of time means, and a simpler procedure means enforcement might work, or you might be able to actually distinguish whether you have a violation or not easily. Keeping it simple for self-policing is the other side of the coin. If we make it simple, where an operator or a club owner can actually police themselves easily and know whether they're within the law, they can protect themselves in a way. Say, well, I'm out there and I'm doing it, I'm checking myself. And all of a sudden, we have people working together, and it's not a big unknown. Okay, I don't know. I know there's some owners here, and I know that in some cases it's very difficult to determine whether you're in or outside of the current law. It's confusing.
Dave, to get a really good representative measurement for LEQ, and where we obviously get the occasional spikes going on, is 20 seconds enough time?
Well, I think when we get into that, it's that LEQ is representing what's going on at that time.
At that time, right.
And if it's over it's evening it out. It's not capturing the high peak. It's giving you kind of an average idea of what's going on and how you're perceiving it. Once we know those numbers and how they affect, we know those numbers, what they mean inside someone's home. We can measure outside their home and say, okay, your home takes out this much. And we know that the arriving sound should be no higher than a certain amount. And then we can backtrack all the way to the front of the source or at the property line or whatever you want to do. Okay? The fact is that if it is over, it is over. And if you're measuring for 20 seconds and it's over, then it is over. Okay? But that gives, that may deal more with the methods, because I think there are people who are interested in not having warnings, and other people who say warnings are important. And currently the police do that every day. They say it's a new day, and they issue a warning if somebody's over. There's all sorts of issues that could happen with operators, like they have somebody new on board, somebody doesn't want to pay attention. A warning seems like a reasonable idea. If people abuse it, then that's another situation. But that gives people an opportunity. So if it is over, you can say, hey, you're over. And then from there, they have to be vigilant about it, right? I think that seems reasonable. But, you know, this is maybe something, if somebody has a comment, you know, and has ideas about this, because we're talking about a lot of different things today, feel free to give the feedback. I think it's very important. Let's take a look at these metrics that we have today. We have L10 and Lmax, okay? L10 represents the sound level that's exceeded 10% of the time during any given measurement. So the time is going by, tick, 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 and you have a sound level, and if the sound level is exceeded a certain amount by 10% of the time, that level is what we hear, or what comes down. It can be on a continuous sound, like a generator, LEQ will be lower. If you have an event that occurs 9% of the time, LEQ will be higher. So L10, LEQ, again, there's reasons to move away from L10 because of what I talked about earlier. It can work, but in this case, I think we're talking about changing the way we go about it. Lmax is interesting because we have in the quarter we have an extremely complex sound field. Okay, you're taking a measurement for 10 minutes at a time. Okay, so your operator has to stand there and for 10 minutes has to make sure that whatever sound, and they're standing away from the source where there's all these other sounds coming around, and when that Lmax happens, that's it. So somebody can walk by and yell, and you have to make sure that that's not it, or you have to reset the measurement. So Lmax doesn't tell us a lot other than, yeah, we have a loud sound, but until you can go back and analyze it, you don't know who made that sound necessarily. You can't, it's difficult to prove unless you do a deeper analysis, and I think that's where things get kind of difficult. That's why Lmax, I don't know that it's going to be very useful for us. There's all sorts of sounds going on. And in a complex sound field, unless you measure close to exactly the source, you're not going to know where this comes from. But it is useful. They use it for plane flyovers. They use it for vehicle pass-bys, motorcycles, to analyze what is the maximum level. Because when you have a pass-by, you need that kind of information. It's so quick. But here you have more continuous sounds. Now you do have peaks, and that is an arguable point. But I think that unless you have recognizable peaks, Lmax may be not as effective as using your LEQ and using your LCEQ. And remember, we're trying to simplify things. Too many metrics, too many things, okay? That doesn't mean this can't be reintroduced or thought about again. I think that's, again, the whole thing is open. Nothing's shut, but I'm just trying to tell you the direction we're heading. And of course, your input is valuable. So, we get into the demos. Great. We're going to look at some different sound sources, and we're going to look at the levels that they produce, and we're also going to look at the effective distance, okay? I've got some things for you to listen to, play, you know, and I hope you enjoy them. Let's see what we got here. Okay, I'm going to reset the sound level meter. What I'm going to do is put up an example of speech, and then we'll talk about what we see up here. Okay, let's see. Okay, this is a demo from our friends at NASA, who are kind enough to create all these excellent sound demonstrations. Let's see what we got here.
All right, I want to thank all of you for agreeing to stay late and work this out. The boys in R&D have sent over the latest version of the product, and it's up to us to come up with a name for it.
We're not going anywhere for a while.
Yeah, I think we can knock this one out quick. It'll be fast. Okay, so this is it. It's under this file right here.
Okay.
Latest version of the product, my friends. There it is, the watch.
A thing of beauty.
Flexible, it's waterproof, it may or may not be triangular in shape, and the R&D boys tell me it won't be sticky when they...
Okay. Now, let's take a look right here. You know what, I just screwed up my speaking. Let me do that again. We'll let him talk just for another minute.
Actually send it to market, so...
I like the that's precise and to the point, that's it, let's go home.
So, I think big feature on this, solar power, everyone.
The solar, that's
solar,
perfect, that's it.
Isn't it time for your employee review?
Okay, our low level equivalent minus our high level equivalent is around 7 decibels, okay? In speech, sometimes we find it to be even lower, okay? Maybe we have a good speaker here. And then you heard the levels in the room. And you see these levels. The equivalent level was 68, okay? The LAS max was 73, and the LAS 10 was 71. So we're in the same ballpark here. Our LC was higher, I believe more so because we have speech through a loudspeaker. So it's a little deeper than you might get someone's voice. Maybe I'll speak for just a second. I'll speak. Let me try that one time. Right now you can see that there the LC, Q minus LAQ is so high because we had so much mechanical noise and very little other noise, a lot of low frequency. So now as I speak, and I'm trying to explain this, you see the meter says I'm at about 61 here, LAQ, and here you see the numbers, okay? And then we're hovering around here, 5, okay, 6 decibels difference, low to high. And I have a deeper voice. If somebody else of a higher voice wanted to speak, I think you'd find, like, perhaps a woman's voice might be a little more delicate than mine. I'm more like Fred Flintstone. So, let's see if we can get a, you know what we're going to do next? Let's take a look at our vacuum cleaner. What I'm going to do is I'm going to start the vacuum cleaner on one side of the room, and you're going to hear it